Hey, what's up, people? We're going to be taking a look at a CRT TV today, and what I think is a first for my channel here. I don't think I've actually ever done a video on like a big CRT TV. Not that I've never fixed any CRT TVs. I used to fix a bunch of these back in like the 90s and like early 2000s. I think the label on the back of this one said that it was manufactured in like March of 2002, so that makes it almost 22 years old at this point. And this is one that I found on the on a curb down here, just like down the street from my house. And it caught my attention due to the fact that it had component inputs in the back. If I can get this working, I have some ideas for it. So we'll see what we can do about it today. And unfortunately, it does not appear to power on. If we plug this in here, I'll put it up to the microphone. You might have been able to hear the little pop there of the capacitors charging up in the switching power supply. And if we hit the power button, it does not like turn on. I can't get it to do anything. I even went online and I tried to determine what remote was designed for use with like this TV. And I think this is the correct remote for it. And even if we try it with the remote to like turn it on, it still does not power on. So yeah, there's definitely something up with it. Disclaimer here: if you've never worked on a CRT TV or you don't know what you're doing with one of these, they are very dangerous. There are like high voltage sections inside of here, including the anode cap that's like up at the top, which puts out like several tens of thousands of volts. So we're going to be very careful when we open this up. And let's, well, I guess I'll turn it around, remove the screws off the back, and we'll see, what the board inside looks like and all that. We'll focus a little bit more on the board itself, because I'm pretty sure that's where the problem's going to be. The buttons do click, so I'm not convinced that it's going to be a power with the buttons, but as you saw, it doesn't even work with the remote. So I don't know. Let's see. There's a bit of signs of something of having spilled on the back of the TV here, but it doesn't look like anything's gone inside. So hopefully we don't find like any liquids or something on the board. I do notice that the connector here for the cable or antenna is a little bent. So I don't know if that means that maybe the board is cracked inside. And as you can see here, this is a 27M800 chassis. The actual model number for this TV is a 27PS55S121. And right there, it's very faint, but it looks like it says manufactured in March of 2002. So there's a few. I've already removed most of the screws from the back. There's like 4 that I haven't removed yet. So I'll take those 4 off, and then we can remove the back and see what it looks like inside. Okay, so that's the 4 remaining screws all removed. Now this back should come off, and I don't think I should have to lay it on its on the glass there to keep it upright. This should work. There we go. Alrighty. And let's see what we got. So nothing that I can tell right off the bat, and it doesn't appear that this thing being a little bent would have damaged anything. It looks like it's just the little tuner case there that's a little, but that's not bad. Well, let me reposition the camera here a bit so we can see the board a little better. So that's about as much as I can get in there with the camera. Looks like I have a plastic clip here that's holding this board from being able to slide out right here on the right side. I'm not sure. Oh, I think there's also one on the left side over here. So I'm going to try to pull those apart and see if the board comes out. There it goes. I don't see like any leaky or popped capacitors or anything like that. There's really not a whole ton of stuff on this board. Looks like maybe there would have been like a big transformer in that section there, but there is absolutely nothing. So the main switching transformer is this one right here. Yeah, I think we're going to be best, or we're going to be able to see things better if we just pull this board out and maybe take a look at the underside. Okay, so before I actually remove the board here, I do want to discharge the anode cap here, or the tube itself. So I've got this alligator clip here hooked up to one end of this really long flathead screwdriver. And then I've got the other end connected here to the ground. This little strap here that goes off to the side and like to all the like the band around the tube. So see if we get a little pop or not. Let's stick this in there. And I didn't hear anything. So this is pretty much discharged. So it's good. Now pull this neck board off. Just gently wiggle it back and forth. Okay, we got that down. Now, there's a few things to disconnect around here. We got some cables that go off to the ports here on the side. We got some, actually both of these right here go off to the side. This here goes to the degaussing coil. And then we just have that ground. And that's it. This should free the the entire main board. Oh, actually, we have the deflection coils. Actually, I'll just leave that in. I actually have other cables that have the same type of connector here, so I can just... Actually, I mean, I'm not even probably going to power this board by itself on the bench anyway, so that should be fine. All right, so I'm just going to take this board to the bench and see what we got. So there's nothing obvious on the board that looks burnt or anything. There is a spot right here that looks a little bit darker where some of these little resistors are. I think this might actually be for the vertical deflection. There's like a small component right there on that heatsink. And this right here would be the transistor for switching the power transformer. That would be for the horizontal drive. I don't see anything here that screams potential problem. It's not right off the bat. Let's take a look at the bottom side. Some of these solder joints don't look awesome, but they don't look broken either. We got a couple of little tiny ICs right there. We got a bigger one right there. And that's pretty much the extent of integrated circuits on this thing, other than the big one here on top. And that's probably going to be the one that has like the jungle and all that. But then we got a little tiny one right here. I think that's probably an EEPROM. That fuse looks good, but I mean, I think it would be if we heard a little pop when we plugged in power. My best guess at the moment, since it doesn't even attempt to power on, is that maybe there's something wrong with like the standby voltage from the switching power supply. Maybe there could be some bad capacitors and, they're just not obvious. I think I did find a service manual for this TV. I just got to dig it up because it's been a while since I found this thing and it's just been sitting around here waiting for me to get around to looking at it. But yeah, let's pull out the service manual and see where exactly like the standby voltage comes from, because I mean, I'm pretty sure it's going to be from like this area here. So yeah, give me 1 second, I'll be right back. All right, so good news is here I do have the service manual, and this is the 27M8 chassis. I might just quickly go through this and see if it maybe can give me some guidance here as to what to check first. Now there is a section here where it talks about error codes, and apparently the LED in the front will blink and it'll allow you to, see what errors are stored in its EEPROM. But the thing is that the thing doesn't even turn on, so I don't believe it's going to be like some sort of error with its ICs. I'm kind of leaning towards a power supply problem at the moment. Oh, hey, look at this. Set is dead and makes no sound. Check power supply IC 7520. So, okay, that might be some good information right there. Well, the cool thing is that on the page right after these repair tips right here, we actually have a troubleshooting flow chart. So let's just go ahead and try some of this stuff out and see what conclusions we can come to. However, this is going to require me to put the board back onto the chassis, I think. Although some of this stuff I could test without turning on the TV, and I could actually use it on the board here. As long as I don't like actually power it on, some of this stuff we can check. Okay, I think this is going to be good here. So if we go back to the troubleshooting flowchart here, in this section we will troubleshoot symptom dead set. It says here that they recommend you use a isolation transformer to protect your test equipment. At the moment, I'm not using anything that requires any grounding, so if I do need one, I do have a isolation transformer I can get, but for the time being, I'm probably just going to plug this straight into the mains here. And then it says apply AC power, do not turn the set on. And we're going to check to see if there's approximately 150 volts DC present on the drain of 7521. Now, if you go back to the board here, it's talking about this pin right here. And that's the drain of the MOSFET that switches the transformer. So we're going to check a voltage between the negative point, which is this one right here on this. This is the large capacitor on the opposite side of the board. We're going to check between here and there and see if we have 150 volts. So let's see what we've got. I'm going to plug this in now. And by the way, I had to pull the cable off the chassis because the cable that I thought I was going to be able to use does not have the same type of connector. And I accidentally moved the camera a little bit. That's about as much as I can zoom in at the moment with the lens that I have on here. So I'm going to have to make do with that. But here we go. So I'm going to put the negative lead here. And I'm going to put the positive lead. Need a better angle here. Let's see. So negative lead here and the positive lead right here. And we have about 165 volts. So that should be okay because it's rectified mains basically. I think it'd be about 150 volts if it was more on the 110 volt input, but we have 120 here, so that seems okay for that one. So we do have 150 volts here, or a little more. So yes, is there approximately 145 volts or more on pin 8 of 7520? And here, 7520 is the IC that controls the switching power supply. So pin 8 would be this one right there. And that looks like it goes down to that resistor. So we're going to check between the negative and that pin there and see what we get. All right, so here we go. So we're going to put negative there, and we're going to put the positive right there. And we have 163 volts. So it says 145 volts or more, so that is definitely more. So we're going to go ahead and say, yes, we do. Is there approximately 10 volts on pin 1 of 7520? So pin 1 is going to be the opposite side. So it's going to be right there. Okay, so once again, let's put the negative right here. I'm going to touch pin 1 right about, I'm going to try to be careful here, right there. We have, yeah, about 10 volts. It's fluctuating a tiny bit. All right, so that's a yes. So it says 2A. All right, and that's the next page here. So that is A right there. Let's see, are there 3.3 and 3.9 volt secondary supplies up to a full value? So we got to figure out where these 3.3 volt and 3.9 volt supplies are. So let me figure that out first, and I'll be right back. All right, so I found them here on the schematics. So 3.3 or 3.9 volt is right here, and 3.3 volt is right here. I've yet to identify where these are on the board, but at least I have an idea of what to look for. So it looks like right here we've got a dual diode, and that's 6565. So at one of the pins of that, we should have 3.9, and the 3.3 should be the common cathode side of that dual diode. So let's try to see where that is on the board, and then we can check both of these pins there, and we can see if we've got our the proper voltages there. It looks like the grounding point is going to be, we can take it from the transformer directly. Okay, so this VAV or BAV70 is this little tiny device right here. So we're going to have to check on this pin right here, and we're also going to check on, it says anode 1, or actually it doesn't specify which one of these two is the one on the schematic, but we're going to check on one of these two here. Should have about 3.9 volts. Then I just got to figure out which grounding point I can use for this. At the schematic here, looks like if I can find this 2567 capacitor, I just need to tap into the ground of that, and then I can measure these 2 volts, or voltages. Okay, here we go. So it's 2567, so it's this capacitor right here. So I'm going to hook up my negative lead to that pin right there, and then I will check the voltages on this pin, and, well, I'll check both of these and see what we have, but one of these should have 3.9. So here we go. Let's go ahead and put this right there. And let's see what we have here. We should have about 3.3 volts right here. And yep, close enough. Now let's see what the other side is. Let's try this pin right here. That has nothing on it. Let's try the other side without shorting on that other pin. So 3.9. That's, yeah, that's correct. So that's working. Okay, so it passed that test, and we can say yes, and it says that all outward appearances indicate the problem is not in the power supply, and it is not being caused by an excessive load on one of these secondary supplies. We can now proceed to check system operation. So now we got to pull out the probes, or the scope. Okay, so for this, we for sure should use an isolation transformer, and I think this is going to require me to hook up the board back to the rest of the set, although it doesn't say anything about turning it on at this point. Oh yeah, right here it says power the set on and observe the scope. All right, so let me try to find a way to do that. Okay, I think I've got a good setup here for testing with the scope, and I've also got a isolation transformer. Now, if we go back to the document here where it says to attach the scope probe to the base of the horizontal driver transistor 7462 and the ground lead to the emitter. Now, when I saw the 7462 horizontal driver transistor, I thought it was talking about the large one that's right here. but this one says 7460. So I thought, well, maybe it's a typo. So I went looking through the schematic, and I saw that 7460 here, that's the big transistor that drives the transformer, the flyback transformer. Here's 7462. So I started trying to find that on the board, and it turns out that 7462 is that little tiny thing right there. So what I've done in order to be able to ground my scope lead somewhere is I soldered in a little loop of wire here, just like a little test lead. Soldered it to that point right there on the transformer because that is ground. I'm going to attach the scope probe to that, and then that way I can take my my actual probe here and I can touch the base of that transistor. And what we're expecting to see there is a horizontal drive waveform that is approximately 1.5 volts peak to peak. Now, this did say to set it to 50 millivolt per division, but I think that's going to be a little too small to see on the scope. So I'll pull that up right there. So I've got it actually set to 200 millivolt per division. And I did set it to 10 microseconds. So let's see what happens if I have to change it. I mean, I can change it, but we'll try it at that first. Let's go back here. And here we go. I actually don't even have the set plugged in yet. I got to get cable over here. Okay, so the set does have power now. So I'm going to try to get this to go over here on the base. Try not to short anything. There we go. Okay, so I've got the test lead there on the base. I'm going to hit the power button. Let's see if anything happens. So actually right now it's sitting at a positive something. We see there that yeah, it goes positive. So, let's see. I'm going to try turning down, or actually I need to turn this voltage up, I think. Let's try to get it to show up on the scope there. There we go. So at 1 volt per division, we actually see something happening there. Here we go. Going to turn it on, or going to hit power on the set. And nope. Whoa. Holy crap, that scared the crap out of me. The set turned on. Yeah, it's powered up. Oh man, I wonder if it's a bad solder joint somewhere. Jeez. Let me go take a look at the front of the screen here. Yeah, so there it is. It's working. So, okay, well, leaning towards a bad solder joint somewhere. Okay, so this thing here says a horizontal drive waveform that is a 1.5 volt peak to peak, but if we look at this here, it's that's definitely more than a 1 volt, 1.5 volt peak to peak because I have it set to a 1 volt per division, so it's about, let's see, about 1, 2, about 2.5. Okay, so I thought I would just kind of like carefully here, like touch around and see if maybe like wiggling something made it turn off. It doesn't seem anything here is like causing any issues at the moment. All right, unfreaking believable. I think the problem might actually be the power button itself. So when I was trying to get it to turn back off so that I could disconnect everything, I was pushing on this and I can't get it to like turn off. I had to put a lot more pressure on it to finally get it to make contact and then the set turn off. So I think what's happening is that when it's in the chassis and you push the button here up in the front, this little lever that's supposed to push on the button itself is causing the board to flex a little bit so that even though you're putting pressure on it, it can't push the button hard enough in order to make it to make good contact, so the set won't turn on. But then you'd say, well, but you can't get it to turn on with the remote either. I think this remote's not working. So if I take this remote and I would shine it at the camera that I have like up here, we should be able to see it flashing. Oh, there it goes. Now it's flashing. Now the TV turned on. Just a few minutes ago when I was messing with it, it was not flashing at all. And see right there, it's not flashing again. So, yeah, if I take another remote, like for example this one here, and I flash it at the, you're probably not going to be able to see it either, but you can kind of see it right there. Like, if I zoom in, can you see it? Yeah, you can kind of see it flashing right there. It's very, very faint, but you can see it flashing. This one, there you go. See, it's not consistent. Sometimes it flashes, sometimes it doesn't. But now it seems to be flashing consistently. So let's see if it works now. Here we go. Have it up here. Oh, wrong button. Here's the power button. Yeah, it's the power button. See, I wasn't pushing the power button. Come on, focus. There we go. See, I pushed the power button, and it takes a lot of force to be able to get it to flash. If I just push it, it doesn't work. But if I push it a little harder, there it goes. So it appears to be a combination of both this button being kind of bad and the button on the remote also being kind of bad. But I mean, I bought this remote used. It's not like it was new, so I guess that kind of makes sense. So as you can see there, I'm pushing it. The set is still on. I don't know if it's gonna, if the 15 kilohertz whine is gonna come through or not. But if I push it really hard, there we go. Now it turns off. So as far as I can tell, there's no serious problems with this set other than the buttons just not working very well. The only thing I did notice though is that this inductor right here is a bit on the whiny side, and I think it's probably because some of the adhesive here that's been used to hold this coil in place as kind of like broken. So if I kind of like touch this winding right here at the bottom, sometimes it's whining pretty bad. But that's not a big deal. That can be fixed. So yeah, I think if I can somehow maybe clean the contacts on that button, because I don't have any replacements, and the way the board was designed, I can't use any other like a 4-pin button or anything like that. But maybe I can like spray some contact cleaner in there. Maybe it'll kind of work its way through that little cap on the top. Maybe that would help. Well, I tried it. It didn't exactly make much of a difference right there. If I push it lightly, I still can't get it to turn on. I have to push it down pretty hard in order to get it to make good contact for it to turn on. So because these buttons, they're not exactly easy to take apart without like cutting off the little plastic like nubs that hold the metal cover in place. I think the best thing to do would be to just replace them. But as I said, I don't have any replacements. Well, since we know that it works, let's test it out. I have a GameCube here on the side. I'm not going to play any games or anything on it. I'm just going to see how the image quality looks. So I'm going to plug in the TV here. And there we go. And I guess now that I think about it, this power button looks like really, really worn down. And that's probably why they probably had to like push it like super hard in order to be able to get it to do anything. So let's see. I'm going to try powering it up. This was after attempting to clean those buttons a bit. Okay, there we go. I had to push like super hard on that. And it finally came on. So there it is. The set's on. I have to switch the input over to AV2 because that's what it is on the back. So let's see. Let's go to the menu here, and it's all in Spanish. So I'm guessing the previous owner was Spanish speaking. Not that I can't speak Spanish. Yo puedo hablar español también. Here we go. I'm just gonna switch it to English so I know. Okay, how the heck do I change the input here? Ah, there we go. I just had to hit the channel button until I got to the... There we go. So, this is working. Do we have audio? I hooked up the speakers. Ah, geez. Even these volume buttons are not working very well. So, there it goes. I had to push super hard on it. It's coming up. Do these buttons work? No. These front buttons are like super hard too. And right there I was pushing the volume up button, but it's going down. If I push the down button, it's it's going down. Come on up button. Nope, it's all going down. So I guess that's one of the reasons they also gave up on this. They couldn't turn the volume up. It just went down. But this one works if you push it hard enough. So these buttons are also pretty crap on this remote. But it is working. So, and actually the image quality is really not that bad in my opinion. It looks pretty clean. That's on S-Video. I hooked up the GameCube there to the S-Video input. So yeah, I think this TV will work just fine for what I have planned for it. But I do have to do like an RGB mod in order to be able to use it for what I want to. So yeah, I think we're going to have to do a part 2 to this TV, and I'll get some replacement buttons, and I'll figure out how I'm going to do the RGB mod, if it can be possible. I mean, I think it is possible with this TV. I believe that I think I looked through the schematics once, just kind of Vaguely. Actually, why don't we do that right now? Okay, so looking at this part of the schematic here, I'm not entirely sure if this is going to be able to be RGB modded. There's a block inside of this TDA 95XX. I'm not sure what it is on this particular TV, but it says RGB/YUV insert. And I think it might depend on what this pin here is. Might set the mode for how these inputs operate. I'm going to have to do a little more research on it to be sure, but it does say here like R underscore V input, G underscore Y input, B underscore U input. And then it does say that for sets with YUV, which is what this TV has in the back, that it would have like these components. And a set with PIP, I'm guessing that means a picture in picture. It says that it would have that, I guess. So this, I'm thinking is like a blanking line. This here, well, actually, that would probably be blanking. I'm not sure what this FBL means. So, yeah, gonna have to do some research and see if it's possible to get this to work with RGB. But as far as this one goes, I think we're just gonna leave it here for now. We do know the TV works for sure, and it's just a combination of issues between the power button and the TV remote. In order to explain why the volume only goes down when we push either the volume plus button or the volume minus, we have to see how this is all wired. And as it turns out, all 5 of the buttons that are on the front panel, they are all connected to a resistor ladder. So what's basically happening here is that the output is going to be an analog voltage that's going to let the microcontroller know, what function you're trying to perform. And so as far as the volume plus and the volume minus, when we pressed volume plus and we saw that it was going down, what's happening is that the resistance in the button itself is so high that the voltage that's produced is basically the same thing as having this 3.3 K resistor here connected to ground, which is what the volume minus button would do. So the resistance that is being formed by pushing this button and this 1.5 K resistor is basically the same as if it was just going this way. So that's why no matter which button we push, the button just goes down. And the channel plus and the channel minus button, they also do the same thing. They just produce a different voltage at this output here. And also the power button. So if this resistance at this button isn't low enough to send out what the microcontroller wants to see, we can actually see how it's all connected over here. There's basically going to be a pull-up on this side. We can see right here, this is where that keyboard input comes in. So it goes through here, goes up this way, and it goes to pin 80 of this controller chip right there. But we can also see right here that we got the 3.9 volts and the 3.3 volts, and those have some resistors here. So that's basically getting pulled up to about 3.3 volts on this line until we push one of the buttons, and then this voltage is going to drop to a certain level. And depending on what that level is how this chip right here is going to interpret what you're trying to do. So yeah, I think that's going to do it for this one. Funny that it totally works. But if you've stuck around to the end here, thanks you all for watching, and I will see you guys around the bench. All right, come on. There we go.